On March 25, 2025, a telescope in South Africa locked onto a faint smudge of light drifting through the constellation Cetus. Within hours, astronomers at 3 separate observatories confirmed the same impossible thing. This object was not orbiting our sun. It was passing through, moving on a hyperbolic trajectory so extreme that nothing in our solar system could have produced it. And when they ran the numbers on its speed, its angle, its composition, the data returned 15 anomalies that, as of right now, no physicist on Earth can fully explain. This is 3I Atlas. It is the third confirmed interstellar object ever detected by humanity. But unlike the first two, Oumuamua and Borisov, this one isn't quietly drifting past us in the dark. It's doing things that contradict what every model says a comet should do. And one explanation being quietly discussed among astrophysicists at Harvard, Cambridge, and JPL is an explanation most scientists do not even want to say out loud. But before we get to that theory, you need to understand what makes this object so deeply, fundamentally wrong. Let's start with how it got here. Every comet humanity has ever studied follows a predictable path. It originates in the Oort cloud, or the Kuiper belt, falls inward toward the sun under gravity, swings around, and heads back out. The math is clean. The trajectory is elliptical. 3I Atlas does not follow this pattern. Its orbit is hyperbolic, meaning it entered our solar system from interstellar space, and it will leave again, never to return. It is a traveler. It came from somewhere else entirely, and the direction it arrived from traces back to a region of space with no known star system close enough to have launched it. Therefore, either it was ejected from a system we have not catalogued, or it has been drifting through the void between stars for longer than our solar system has existed, but that's just the trajectory. The real problem started when astronomers pointed better instruments at it. The first anomaly was the coma, the glowing shell of gas and dust that surrounds any comet as it approaches the sun. 3I Atlas has one. Oumuamua, the first interstellar object, did not. That is important because it means this object is actively outgassing, releasing material as it heats up. That sounds normal, except the composition of that coma does not match any comet we have ever seen. Spectral analysis revealed chemical signatures that are, according to researchers at the European Southern Observatory, inconsistent with known solar system volatiles. In plain language, whatever this object is made of, it did not form in a system like ours. And that was only the second anomaly. The third stopped an entire observation team mid-session. When a normal comet outgasses, the jets of material shoot away from the sun. That's basic thermodynamics. The sun heats one side, material sublimates off that side, and the jet pushes in the opposite direction. Every comet, every time. 3I Atlas has a jet that points toward the sun, not away, toward it, as if something is pushing material forward against every thermal model in existence. The team at the Gemini North Telescope in Hawaii confirmed this independently, and when they published their preliminary findings, they used a word that rarely appears in astrophysics papers: unexplained. So let's stop here for a moment, because we're 3 anomalies in, and already we're dealing with an object that shouldn't exist in its current orbit, is made of materials that don't match our solar system, and is ejecting matter in a direction that violates known physics. But here's what makes this genuinely unsettling. There are 12 more anomalies, and they get worse. Anomaly 4 is the brightness curve. As 3I Atlas moves through space, its brightness fluctuates. All comets do this to some degree. They rotate, they have uneven surfaces, they tumble. But the brightness variation on this object follows a pattern that does not correspond to any natural tumbling motion. It is too regular, too rhythmic. It is almost as if the object's reflectivity is changing on a cycle, like something opening and closing or rotating with a geometry that is not spherical, not oblong, not any shape we associate with a natural body. Meanwhile, Avi Loeb, the former chair of Harvard's astronomy department, the same scientist who argued Oumuamua might be an artificial object. Lightsail has been watching, and what he is saying about 3I Atlas is more measured than you would expect. He is not screaming aliens, he is doing something more unsettling. He is publishing paper after paper, documenting each anomaly with rigorous math. And in a statement released through the Galileo Project, his research initiative dedicated to studying anomalous interstellar objects, he said this: "The accumulation of statistically significant deviations from expected cometary behavior warrants serious scientific investigation, not dismissal." In other words, stop laughing and start looking. But the scientific establishment is in a difficult position. Anomaly 5 through 9 all compound the problem. The object's non-gravitational acceleration, meaning it is speeding up or changing direction in ways that gravity alone cannot account for, mirrors what was seen with Oumuamua. That was the anomaly that launched 1,000 headlines back in 2017. With Oumuamua, scientists could argue the acceleration was caused by outgassing we simply could not detect. With 3I Atlas, we can see the outgassing. We can measure it. And it does not produce enough force to explain the observed acceleration. Therefore, something else is pushing this object, something unidentified. Anomaly 6, the dust-to-gas ratio is inverted compared to every known comet. Anomaly 7, the object's nucleus appears to have an albedo, a reflectivity that changes over time as if its surface is transforming. Anomaly 8, its response to solar radiation pressure is inconsistent with its estimated mass. Anomaly 9, the tail structure splits in a way that suggests multiple outgassing sources on a body that, by all estimates, is far too small to have that many active regions. Every single one of these taken alone could be explained away. An unusual composition, a weird shape, an unknown volatile, but together they form a profile that does not match anything in our catalog of natural objects. And that is what Anomaly 10 made painfully clear. When researchers tried to model 3I Atlas as a conventional comet, they plugged in every known variable and ran simulations across dozens of possible compositions and structures. But the models failed. Not partially, completely. The object's observed behavior could not be replicated by any combination of natural parameters. The models broke. And according to a team at the University of Maryland Astronomy Department, the statistical probability of a natural comet exhibiting all 15 anomalies simultaneously is, and I want you to hear this number, less than 1 in 10 billion. So what is it? There are 3 theories being discussed seriously, and one being discussed very quietly. The first theory is the most conservative. 3I Atlas is a natural interstellar comet, but it formed in a stellar environment so radically different from our own that our models simply don't apply. A system with different metallicity, different radiation levels, and different chemistry. This would make it exotic, but natural. The problem with this theory? It doesn't explain the jet direction. It doesn't explain the non-gravitational acceleration, and it doesn't explain the brightness pattern. The second theory proposes that 3I Atlas is a fragment of a larger body, perhaps a planet that was destroyed in its home system, or a chunk of a differentiated object with layers of unusual material. This could explain the strange composition and the multiple outgassing sources, but it still does not explain the acceleration. Fragments do not typically exhibit regular brightness cycles. The third theory is the one that keeps showing up in Avi Loeb's papers, in late-night discussions at astronomy conferences, and in the careful hedging language of NASA press releases. 3I Atlas is not a natural object. Now, before you dismiss that, consider what we actually mean. We're not talking about a flying saucer. We're talking about the possibility that this object is a piece of technology, a probe, a defunct piece of equipment, something manufactured by an intelligence launched from another star system and now drifting through ours, outgassing not because of cometary sublimation but because of degradation, material breaking down, systems failing, a machine slowly dying in the vacuum between stars. This is the theory that Loeb has not endorsed outright but has explicitly refused to rule out. And the reason he refuses to rule it out is because of what happened with Oumuamua. In 2017, the scientific community spent more energy mocking the artificial hypothesis than investigating it. By the time Sirius telescope time was allocated, Oumuamua was gone. We missed our window, and Loeb has said publicly that he will not let that happen again. Therefore, the Galileo Project has already redirected resources. The Vera Rubin Observatory, set to come fully online in the coming months, has 3i Atlas on its priority observation list. And privately, sources within the project have confirmed that proposals have been submitted to multiple space agencies for a flyby mission. An actual spacecraft would be launched to intercept 3y Atlas before it leaves our solar system. But here's the problem. The window is closing. 3i Atlas is moving fast, not as fast as Oumuamua, which gave us almost no time, but fast enough that any mission would need to launch within the next 18 to 24 months. And no space agency on Earth currently has a vehicle ready for an interstellar intercept. Meanwhile, the anomalies keep accumulating. Every week, new observation data comes in, and every week the gap between what we see and what our models predict grows wider. There is a moment in every great scientific mystery where the data stops whispering and starts shouting, where the polite academic language of further study is warranted gives way to something more urgent. We may be at that moment right now. Because somewhere out there, roughly 400 million miles from Earth and closing, an object that came from another star is doing things we cannot explain. It is not behaving like a comet. It is not behaving like an asteroid. It is not behaving like anything we have ever seen. And in a few months, it will be close enough for the most powerful telescopes ever built to get their best look. What they see could confirm the boring answer, a weird rock from a weird place doing weird things. Or it could confirm something else entirely, something that changes the way we think about our place in the universe, something that answers the oldest question our species has ever asked. We're watching. And for the first time in human history, whatever it is, it might be close enough to watch back.